All right, this is our last final farewell for Managerial Sciences 3100, MGS 3100 for spring 2010. It has been great working with all you guys. You've really impressed me. Sometimes you've impressed me more than others, but hey, that's normal. So let's get ready for this final exam. And I'm going to walk through these 20 problems here, and this should get you guys prepared for most of the problem sections. Make sure that you study all those concepts as well. Look back at that sample final exam. Look at the exams 1, 2, and 3 that you've already had, and you should be ready to go for this exam for the final. All right, first, let's take a look at the first problem here. We have the break-even point for a profit model is 600 units, and fixed cost $100,000. So what's the contribution margin? So how many we know that we have to make 600 of these things just to break even. So how much is each one contributing to profits? So it's a real simple problem here, and we'll just do it. We'll do it up in Excel, and it's just going to be 100,000 divided by the 600. So that's going to be, oh, did I put the right in there? I may have put a million in there. I think I put a million. Yep, I put a million by mistake. So it's 166.667. If we take a look at that formula, we have 100,000 divided by 600. You should do that on your hand calculator real easily, and you come up with the answer there pretty quick and easy. All right, what about CPK? Well, we know that the formula for CPK, which is our Process Capability Index, is going to follow the form like this. It's going to say the CPK is equal to the minimum of two numbers. Let's say that the minimum of 1 and 1.5. In this case, even if I do it in a spreadsheet, if I don't put the parentheses in there, it'll actually calculate it for me. 1 comma 1.5 is 1. So the answer in this case would be 1. So really that's kind of the way it would be expressed, would be this minimum of 1 and 1.5. But what in the world does that? So what does that CPK mean? Well, a CPK means if it is greater than 1, that means that the process is actually capable. That is going to meet the specification. If it's less than 1, that means it's shifted either closer to the lower spec limit or closer to the upper spec limit, and you've got a problem. So that's kind of how to interpret that CPK. Take a look in your textbooks back on page 354, 355 for an example of computing CPK. And this is a little bit different from the process capability ratio, which is covered on page 353, but they're certainly related. All right, so take a look at that in the text just to make sure that you feel comfortable with that. All right, well, what is our next one? The next one is question number 3, and that is, what is a range chart and what is plotted? Well, a range chart, plots or graphs. Plot is means the same thing as graph, Amanda. And so a range chart is going to take a look at each of your samples that you take, and it's going to give you the range, the upper and the lower, the smallest value and the lowest value in your range. And that'll tell you whether your process is getting more variable over time. So it's going to plot out the high value and the low values on a chart over time. So you'll be able to see, for the last, every time it's been checked every day for the last month, for the last 30 days, you're going to see has that range gotten bigger or smaller. All right, the next one, we have a machine breakdown in a day of 0, 1, or 2, and these are the probabilities. This 0.2 is the probability of having 0 breakdowns. 20% of the time it's not going to break down at all. 40% of the time it's going to break down once, and 40% of the time it's going to break down 4 times. So how are we going to solve that? Well, that's not that tough of one to solve either. We'll move this over here to the side so that I can see it. And we'll just do this in Excel real quick. Alright, so I've got Excel up here, and certainly this would be a real quick, easy one to do on a piece of paper as well. And in this case, we are going to have, let's pull this back up here so we can look at it for a second. We've got 0, 1, and 2, and here's our probabilities, and then we have random numbers. So the first thing I'm going to do is just make up a real quick table here of my probabilities, and we have a chance of 0 defects, 1 defect, and 2 defects. And those probabilities are 0.2, 0.4, and 0.4. And so this is going to be the maximum value of that one is going to be 0.2. So that'll be the same here. So the maximum value for this range is going to run from 0.2 up to 0.6, which is going to be this one plus this one. So now we're going to know if we're between 0 and 0.2, it's going to be 0. If it's between 0.2 and 0.6, we're going to have 1 defect, again if we're rolling the dice here. And then finally, the max is going to be 1. So between 60% and 100, we're going to have 2 defects. Again, this is if we're pulling up a random number between 1 and 100. Alright, now let's see what happens. We have our random numbers now, and those were 0.73, 0.4, 0.2, 0.65, 0.12, 0.9, 0.32, 0.44, 0.76, and 0.55. I'm going to have to change the rounding on these a little bit so that we can see those values again. Actually, going to make those columns a tad wider so we can see all those. There we go, that's looking better. So if we have a 73, is that below this number? No. Is it below this number? No. Is it below this number? Yes. So we have 2 defects. Alright, so we have next we have a 0.4. Is it below that number? Nope. Is it below that number? Yep. So we have 1 defect. We have a 0.2. Is it below this number or equal to it? Yes. So we have 0 defects. Alright, 0.65. Equal to or below? Nope. Equal to or below? Nope. Equal to or below? Yep. 2 defects. And so on. So we have 0 defects, we have 2 defects, we have 1 defect, we have 1 defect, we have 2 defects, and we have 1 defect. So how many times do we have 1 or 2 defects? 1, 2, 3, 4, 5, 6, 7, 8. So 8 out of 10, so the answer is 0.8 or 80%. Okay, that's the answer to that one. Alright, let's take a look at our next question that we have up here. In this case, we have a profit equation for making a good is 3x minus 43. The profit equation for buying it is going to be 4x minus 8. So let's take a look at that. All we got to do to come up with the crossover point, which is where these two things have the same profits, is just set them both equal to 0. So let's just get rid of all this. I'm sorry, we set them equal to each other and solve for x. So that would be, if we were just going to do this out on a piece of paper, it'd be 3x minus 43 is equal to 4x minus 8. Whoops, minus 8. Now that looks like a real pain in the butt, but if we're just going to simplify that in algebra, we're going to move the x terms to one side of the equation and then move these numeric terms to the other side of the equation. If I want to move a number from this side to this side, I just subtract it, or move it from this side to this side, I just subtract it. So if I take the 3x, subtract it from the 4x, I get on one side of the equation, I get an x, just an x. And then I've got to take the 8 and move it over here. So if I want to take a negative 8 and move it over here, I'm going to add 8 to that side. So if we have negative 43, and we're going to add 8 to that, we're going to get a minus 35. And you remember on the other side of the equation, since we just took the 4x and we take away 3 x's, so we just have 1 x left. So the answer is negative 35. So the answer to that question is negative 35. That means that